Need to extract HTTP headers in your FastMCP tools, but tired of dealing with missing request contexts or cryptic errors when the session isn't ready? You'll see how to safely access headers like authorization tokens, user agents, and content types, even when the MCP session hasn't fully initialized, using FastMCP's built-in dependency helpers. The pattern handles edge cases gracefully, so your tools stay reliable whether they're called by AI, APIs, or direct users. From FastMCP, import FastMCP. From FastMCP server dependencies, import get HTTP headers. MCP equals FastMCP, name equals headers dem. At MCP, tool. Async def safe header info, dict. Safely get header information without raising errors. Hash get headers, returns empty dict if no request context. Headers equals get HTTP headers. Hash get authorization header. Auth header equals headers, get, authorization. Is bearer equals auth, header starts with, bearer. Return. User agent, headers get, user agent, unknown. Content type, headers get, content type, unknown. Has auth, bool auth header. Auth type, bearer if is bearer else other if auth header else none. Headers count, len headers. This demonstrates the dependency injection pattern combined with context isolation for request handling. The code shows how to access HTTP request metadata through a dedicated dependency function, rather than direct framework coupling. What makes this distinctive is the separation between the request processing layer and business logic, with dependencies injected at runtime. The pattern works by providing a clean abstraction layer where request-specific data like headers becomes available through simple function calls. The framework manages the context lifecycle automatically, ensuring dependencies are only available during active requests while keeping your tool implementation unaware of the transport mechanism. This creates a clear boundary between infrastructure concerns and application logic. This approach solves the common problem of request data access in modular systems, where you need header information or authentication details without tightly coupling to web frameworks. It's particularly valuable in RPC systems, microservices, or any architecture where tools might be called through multiple transports. The trade-off is a slight indirection cost, but the benefit is significantly improved testability and transport independence. Let's break it down. From FastMCP, import FastMCP. From FastMCP server dependencies, import get HTTP headers. Imports FastMCP for creating AI callable tools and get HTTP headers to safely access HTTP request metadata. These dependencies enable header inspection without raising errors when no request context exists. MCP equals FastMCP, name equals headers dem. Initializes the FastMCP instance named headers demo, creating the core container for all AI callable tools. This is the entry point for defining your toolset, where you configure the namespace and shared resources before registering individual tools. At MCP, tool. Async def safe header info, dict. Safely get header information without raising errors. Hash get headers, returns empty dict if no request context. Headers equals get HTTP headers. This defines an AI callable tool using FastMCP's decorator pattern. The get HTTP headers function safely extracts request headers, returning an empty dictionary when no request context exists, which prevents runtime errors in non-HTTP environments. Hash get authorization header. Auth header equals headers, get, authorization. Is bearer equals auth, header starts with, bearer. This extracts the authorization header safely using get with a default empty string, preventing key error if the header is missing. The starts with check then identifies bearer tokens, a common authentication pattern for API requests.
Return. User agent, headers get, user agent, unknown.
This safely extracts the user agent header using get with a fallback. The pattern prevents key error exceptions when headers are missing, ensuring robust operation even with incomplete requests. Header safety pattern. The get HTTP headers. Dependency provides safe access to HTTP headers in FastMCP tools, returning an empty dictionary when no request context exists rather than raising errors. Authorization headers require explicit string checks since get authorization returns an empty string rather than none when missing. This pattern enables robust header processing without defensive try-catch blocks throughout your codebase.
The header that refuses to be missing becomes the most reliable presence.